Hi everybody. Today we're going to talk about linear key features. We're talking about y-intercept, we're talking about slope, and x-intercepts. Okay, so those are the main things that we're going to look at today. First, let's get some definitions out of the way just so that we understand what it is that we're talking about. The y-intercept is where your graph crosses the y-axis. So whatever your function is, every function has some kind of y-intercept. Okay, so where the function crosses the y-axis. It doesn't matter if this is a linear function or a quadratic function. Whatever the function is, wherever it crosses the y-axis, that's a y-intercept. Okay? Now your slope is, in Algebra 1, your slope is limited to just your linear functions. Okay? So when we talk about slope in Algebra 1, that's that constant rate of change in a linear function. Okay? It's that constant. And normally when we see slope, if we're talking about a graph, we're looking at rise over run. If we're given 2 points, we're looking at the change in the y values over the change in the x values. So a lot of times you're going to see slope referred to as rise over run. And that's what we're going to look at here in a few minutes when we look at some graphs. Or you might see it referred to as the change in y over the change in x. Okay, and that's what that little triangle means. It means change in. Mathematicians can be a little bit lazy sometimes, so we want symbols instead of having to write everything out. Okay. Now, if you see something about the rate of change, you have a question asking you what is the rate of change for this problem. It's asking for the slope, but it's asking for the slope with unit rates attached, okay? So it could be, instead of just 3 over 1, it could be $3 for every one toy, okay? So that's what it's asking about. When it asks about rate of change, it's asking about the slope with units. Okay? All right, a couple more definitions for us. We've got x-intercept. The x-intercept, just like the y-intercept, is where the function crosses the x-axis. Okay? So again, any function, whether it is linear or quadratic or cubic, if it crosses the x-axis, it has an x-intercept. Okay? And the zero, if you hear zero of a function, or you're asked to find the zero of a function, that's just the x value of the x-intercept. So when you're asked to find this zero, then you're just going to write it as x equals something. Okay? X equals whatever that x value is. Okay? Your x-intercept, it's asking for a point, so that's always going to be the x, and then your y is going to be 0. And when we talk about y-intercepts, that's always going to be 0 and then your y. Okay? Just the basic definitions to help us out here. Just real quick, I'll draw a quick sketch just to kind of show you what I'm talking about when we use these definitions. Okay? I'll try to get a straight line here, as straight as I can. All right? Yeah. All right. So if I'm drawing my line there, there's my linear function. Okay? Then my y-intercept is right here. Okay, let's call that y-intercept 0, 1. Okay, my x-intercept is going to be right here. So we're going to call this x-intercept -2, 0, which means that my 0 is going to be x equals -2. And then my slope, I'm going to go up 1 and right 2. Okay, so my rise and my run. So my slope, my rise is 1, my run is 2. So my slope is 1/2. Now, why do we need to know slope and y-intercept, x-intercepts, all that good stuff? Your slope and your y-intercept can be used to write the slope-intercept form of an equation. So y equals mx plus b. Okay. Now the y value of your y-intercept is your b, and then your slope is your m. So for this sketch here, y equals 1/2 x plus 1. Okay. And we'll look at a couple of other graphs that we can find slope and y-intercept, and we can write the equations pretty easily. But for this particular linear equation, this particular form of a linear equation, all we need is a slope and a y-intercept. Let's look at a couple of pre-done graphs. Now this one is a graph that actually has some labels on it. This is looking at someone's total savings based on the number of weeks that they've been saving. Okay, this is a situational graph. It applies to a certain situation. And when we have situational graphs, sometimes we do not have certain key features. Okay, so if you notice, we have our y-intercept right here. Okay, so our y-intercept is at 0 and 120. If we want to find our slope, I can look here, and let's say I want to go, let's do this one. I want to go up and over. I just want to connect these points in a triangle. So I'm going up, but I have to pay attention to my intervals. So from 160 to 200, it went up 40. And then for the weeks, it went from 2 weeks to 4 weeks, so it went over 2. So my slope is going to be $40 over 2 weeks, which reduces down to $20 for 1 week, or just 20. Okay. I want to look for my x-intercept now. And if you see, here's my x-axis down here. This is my y-axis up here. That line does not cross the x-axis. It does, but not in this situation. If we were to extend this line out, eventually it would cross the x-axis down here in the negative portion of the x-axis. But because we have a specific situation where we can't have negative values, the x-intercept does not apply to this situation. Okay, and that happens sometimes. You get certain situations where, yeah, you're just not going to have an x-intercept. So, and in that case, you just kind of make a note that it doesn't apply in this situation, or that it doesn't make sense in this situation. And we move on. Since we don't have an x-intercept, we can't have a 0, okay? But I want to go ahead and write the equation for this. Let's say I want to know how much money will be in this account after 52 weeks, a year, okay? But I don't want to have to sit there and plot out this whole graph for it. So what I'm going to do is write the equation. Now remember, my y-intercept, the y value is my b, and my slope is my m. So when I put it into slope-intercept form, it's 20x plus 120. And if I want to know how much money is going to be in that account after 52 weeks, I just plug a 52 in for my x. Okay. All right. Let's try another graph. Okay. Now this one does not have a situation to it. It's just a generic line. Okay. So our y-intercept is down here at 0, -3. My slope, if I were to go over 1, I can go up 3. So my slope is 3/1. My x-intercept is here at -1, or sorry, at +1, 0. Okay. And so my 0 is going to be x equals 1. Okay. There are all my key features. Okay. I want to write my slope, my slope-intercept form of the equation. Y equals, here's my b, here's my m, and I could simplify this m to just be 3. So 3x minus 3. Okay, I'm going to clean that up a little bit. How's that, guys? All right, bringing back memories. And this is going to be our last example for today. Again, it's just a generic line. There's not a situation to it. We don't have to worry about money or anything like that on this one. We're just looking at the line. So my y-intercept is up here at 0, 6. Okay. My slope. Now this slope looks a little bit different than the others that we've been looking at. Okay. This time the line is going down. The other two examples we've had, the line was going up. So on a case like this, when the line is going down, our slope is going to be negative. Okay. So this is a negative slope. And we're going to see that because to get to another pretty point, we'll just call it that one. We're going to go over 2. We're going to go right 2, and that's a positive direction. But then we're going to have to go down 4 to get to that point. That, when we go down, that's a negative direction. So that's where our negative is going to come in. So -4 over 2, and that's going to simplify to -2/1, or just -2. Okay. Now my x-intercept is right here at 3, 0. So my 0 is at 3. X equals 3. Okay. Now to find my slope, it does not matter which of these points I picked. Any pretty point, any nice point on the line we could have used. I just happen to use the y-intercept and then the point at 2, 2. Okay. All right. And if I want to write this equation, y equals, again, +6 is my b, -2 is my m, so -2x plus 6. All right, guys, that's your review of key features of a linear function. And I will see you later. Have a great day.